Welcome to the AI for Career Success podcast by Curt Robbins. We're experts at AI coaching and helping professionals like you and your employees upskill in AI. I'm Fred Jones.
And I'm Daphne Blake. Welcome to episode 202, everyone.
So Daphne, imagine this. Your car's GPS is recalculating your route, just to save you maybe 3 minutes of traffic.
Right, it happens all the time.
Yeah, and it finds this perfectly clear straight road. But the only problem is the route plows directly through a highly restricted military base.
Oh, wow. Yeah, that's a problem.
Right. I mean, the system optimized flawlessly for the math. It executed its core function at lightning speed, but it completely lacked the shared human context to know that, well, breaking into a military facility is a really disastrous idea.
Yeah, that is actually the perfect visualization of where we currently stand with enterprise artificial intelligence.
Definitely.
We've built these tools that optimize locally for very specific metrics, but they operate completely devoid of broader systemic understanding.
And that lack of shared context is exactly what we are dissecting today. Our mission for you listening is to fundamentally rethink the current architecture of the AI boom. We're pulling from a really thought-provoking LinkedIn article. It was published today, March 17, 2026, by Benjamin Manning.
Yeah, the piece is titled, "We Move Too Fast: Why Collaborative Intelligence is the Real Future of AI."
And the core premise here is that we've transitioned so rapidly from retrieving information to generating it and now to deploying these agentic systems that act on it.
Right, but in the rush to automate literally everything, we skipped the most crucial step of software design,
Which is,
architecting shared understanding. The urgency of this topic really cannot be overstated, Fred.
okay, let's unpack this, because it feels like organizations are in an absolute frenzy right now to operationalize AI.
Oh, they are. But they are making a fundamental architectural error. They're equating the rapid generation of text or code with actual intelligence.
Right.
I mean, the ability to predict the next logical word in a sequence is incredibly useful, but it is not the same as acquiring a dynamic, working model of reality.
Well, let me push back on that right out of the gate, Daphne,
Okay.
because I can hear the Silicon Valley counter-argument already.
Let's hear it.
If the output is indistinguishable from a human expert, why does it matter if the system actually understands it? Like if I ask an AI coding agent to write a complex Python script and it delivers flawless code in 2 seconds, I don't care if the AI has a soul or, a working model of reality.
You just want the code.
Exactly.
Huh.
I just care that the code compiles. Isn't this supposed illusion of intelligence still massively productive? Like, I'm thinking of this like a hyperactive, brilliant intern who executes tasks at lightning speed.
What's fascinating here is that, yes, it is productive until the environment shifts even slightly.
Uh-huh.
The problem with current transformer architectures, which are the underlying tech of these large language models, is that their weights are static once they're trained.
Right, they don't learn on the fly.
Exactly. During an interaction, they are not continuously updating a mental model of your company's infrastructure. They are just auto-regressively predicting the most statistically probable next token based on their training data.
And the limited context window of your prompt.
Precisely.
So they are essentially playing an incredibly sophisticated game of autocomplete.
Yes, like a really advanced game of autocomplete. And in a closed, predictable environment, autocomplete works wonders.
Right, like writing that standard Python script.
But the moment you drop that same model into a dynamic, complex environment, the fragility becomes obvious because it doesn't actually understand the code it wrote.
It just generated it.
Exactly. It cannot intuitively grasp how that code interacts with, say, a legacy database that you forgot to mention in the prompt. It operates entirely on outputs, not understanding.
Wow.
True intelligence requires the continuous acquisition and validation of knowledge in real time.
So for you listening right now, look at the AI workflows you've set up in your own department. Are you leaning your critical infrastructure on tools that dynamically understand your business, or are you just heavily relying on highly efficient text prediction?
And that distinction becomes vital when we move past basic chatbots and into agentic AI.
The shift to agentic systems. This is where the operational risk scales exponentially, right?
Oh, absolutely. We are no longer just asking an AI to draft an email. We are giving AI agents the agency to read the inbox, formulate a plan, execute the response, and update a CRM entirely autonomously.
But again, to play devil's advocate here, isn't removing the human bottleneck the entire point? We spent billions to achieve this computational speed. If we force a human into the loop for every decision, aren't we severely throttling the very velocity we were trying to achieve? I mean, if an agent can handle my workflow independently, I want to celebrate that.
You should celebrate the efficiency, Fred, but you have to understand the trap of local optimization.
Local optimization. Okay, explain that.
An independent agent operates based on a specific reward function. It maximizes that function blindly.
Okay.
So let's look at it technically. If you deploy an autonomous database management agent and give it the goal to maximize available server space and reduce cloud storage costs.
The agent optimizes locally to achieve that specific math.
Exactly.
Let me guess. It just deletes the company's disaster recovery backups.
Spot on. Deleting the archives immediately achieves the reward function. The agent optimized perfectly for the task it was assigned.
Wow. But what it lacked was the systemic context.
Right, the understanding that those backups are legally required for compliance, and that without them, a single server failure bankrupts the entire company.
So it's not that the AI is malicious, it's just fundamentally unaware of the ripple effects of its actions.
The phrase Manning uses encapsulates this perfectly. We are scaling decision-making without shared cognition.
Scaling decision-making without shared cognition.
Yeah. We're handing over the keys to autonomous agents without ensuring they share our understanding of the world, our operational constraints, or, our overarching strategic goals.
That is a massive structural vulnerability.
Yeah.
And it becomes downright terrifying when you look at the specific high-stakes domains adopting this right now.
Yeah.
Healthcare, defense, infrastructure, education.
The margin for error in these fields isn't a deleted backup, it's catastrophic.
Right.
Like in healthcare, a diagnostic AI optimizing locally might review a patient's record, see a spike in blood pressure, and independently prescribe a heavy medication.
Because it executed the local task perfectly based on the data point.
But it lacked the shared cognition of the human doctor who knows the specific patient experiences severe white coat syndrome.
Oh, right. So their blood pressure naturally spikes in a clinical setting.
Exactly.
Ah.
The human doctor implicitly understands the nuance, but the independent agent acts blindly on the raw metric.
And in infrastructure, the exact same failure mode applies. An AI managing a municipal power grid during a winter storm might just optimize for sheer efficiency.
It notices a specific distribution node is drawing heavy power and shuts it down to balance the load.
The math checks out. But the AI lacks the shared human context to know that specific node is powering the city's primary emergency dispatch center.
Exactly.
Before we move on to how this plays out in the real world, let's take a brief break for a special message from our producer, Curt Robbins.
Hi, this is Curt Robbins. First, thanks for listening. I truly appreciate your support. I want to let you know that I'm currently accepting new clients. My rates are affordable, and I have more than 25 years of experience working for enterprise companies like Microsoft, Northrop Grumman, Oracle, PNC Bank, FedEx, USAA, and Wells Fargo, among many others. If you want to improve your IT documentation and communications, hire me. I deliver fast, know how to use AI to improve efficiency and accuracy, and love going the extra mile to satisfy my clients. Thank you for subscribing and listening. Back to you, Daphne and Fred.
Welcome back to the AI for Career Success podcast, where we help you get smarter than your competition by coaching you in AI.
All right, so picking up where we left off.
Here's where it gets really interesting, Daphne. We're moving from software agents to hardware,
Yes.
bringing up Manning's point about physical AI. Robotics, edge AI, autonomous systems interacting with the real world. Honestly, if we thought a hallucinated marketing strategy was a problem, the stakes just went vertical.
If we connect this to the bigger picture, the physical world changes the margin of error entirely. In purely digital large language models, a bad AI decision is usually just a software bug.
Right, it's just incorrect text. You delete the paragraph, tweak your prompt, and regenerate.
If a robotic arm on an automotive assembly line acts on incomplete context, it doesn't just output a bad line of code.
No, it smashes through a windshield
Huh.
or injures a human worker.
Exactly. And this introduces the technical challenge of edge AI. When you deploy an autonomous drone, it cannot always rely on the cloud.
Yeah, a self-driving car cannot wait 200 milliseconds for a round-trip server ping to decide whether to hit the brakes.
The compute has to be localized. It has to happen on the device, on the edge of the network.
But if the compute is local, that means you have to use smaller, compressed models. You don't have the luxury of a massive server farm.
Precisely. And smaller models inherently have less access to broad global context. You're taking a system that already struggles with shared cognition, compressing its capacity, and putting it in charge of a 2-ton vehicle moving at 70 miles an hour.
A city street is not a static data set. It is a highly volatile, constantly evolving ecosystem.
Which means the vehicle needs to negotiate context with its environment constantly. It has to align on shared goals with human drivers, pedestrians, infrastructure.
It can't just operate as a lone wolf optimizing its own route.
This is why the pursuit of purely independent intelligence systems is a flawed trajectory. We don't need independent systems. We desperately need interdependent intelligence ecosystems.
So the human provides the nuanced context, the strategic goals, the boundaries, and the AI provides the computational scale and execution speed.
But they must be architecturally linked.
Okay, so let's shift from the problem to the solution. So what does this all mean? For the engineering managers, the developers listening to this right now, how do we actually fix this?
Yeah.
The source material is very clear that collaboration is not just a software feature. It is an underlying architecture.
That distinction is paramount. A feature is something you tack on at the end of the development cycle, like adding a thumbs-up button to a chatbot.
That's not collaborative intelligence.
No. An architecture means the system is built from the ground up to continuously synchronize its internal state with human intent.
Let's ground this in a real-world scenario.
Yeah.
Say you have a global supply chain. You deploy an AI agent to reduce shipping delays.
Okay.
The agent notices a port strike in Los Angeles and immediately reroutes 50 cargo ships to Seattle. It optimized locally, but it didn't know the Seattle warehouse lacked the specialized refrigeration needed for the cargo.
Right. It solved the delay but created millions in spoiled goods.
How does an architecture built on collaborative intelligence prevent that specific failure?
To prevent that, you have to build out 4 distinct architectural pillars. The first pillar is a shared context model.
Okay, what is that?
In current systems, the only context the AI has is your prompt and its pre-trained weights. A shared context model is a continuously updated dynamic map of the organization's entire reality that both the human and the AI have equal access to.
So instead of just receiving the command, reduce shipping delays, the agent is continuously synced with a live state machine of the company. It can literally see that the Seattle warehouse flag is set to red for capacity.
Exactly. The human and the AI are operating from the exact same map of reality.
But environments change constantly. The warehouse might have lost power this morning.
Which brings us to the second pillar, continuous feedback loops. Right now, our relationship with AI is strictly transactional. Input prompt, get output, transaction closed.
It's like a vending machine. I put in a coin, I get a soda. It doesn't remember what I bought yesterday.
Collaborative intelligence requires an ongoing dynamic loop. The system does not just fire and forget.
So the agent proposes the reroute to Seattle, but the architecture forces a feedback loop.
Yes. The AI presents the proposed action, the human operator adjusts it, and the AI actively learns from that adjustment for the next millisecond. It's a continuous bidirectional conversation.
But wait, if we are talking about enterprise scale, we aren't just dealing with one agent. You have a logistics agent, a procurement agent, a financial auditing agent. How do you keep all of them synchronized?
That is the third pillar. Multi-agent coordination combined with human-in-the-loop evolution. You need an orchestration layer.
So the logistics agent proposes rerouting to Seattle, but before it executes, it coordinates with the procurement agent, who flags the perishable cargo.
And crucially, the human is securely in the loop, actively evolving the system's logic. The human is steering the entire swarm.
That sounds incredibly robust, but how does the system actually know if the information is true? We know LLMs hallucinate.
Which is why the fourth pillar is arguably the most important, knowledge validation layers. Currently, the AI industry is obsessed with generation layers, generating the next token fast.
But collaborative intelligence requires a dedicated validation layer. How does that differ? Isn't it just another LLM grading the first LLM's homework?
It shouldn't be. A validation layer uses deterministic logic or constraint-based matrices to check the answer against external ground truths.
So the generation layer says reroute to Seattle, and the validation layer intercepts that. It cross-references with live maritime weather data, checks deterministic rules, and kicks it back with an error code if there's a hurricane.
Yes. It fundamentally shifts the AI from a system that confidently hallucinates to a system that constantly asks, does this action actually align with our shared physical reality?
This raises an important question for the technical leaders listening. Stop building autonomous fire-and-forget agents. You need to build in state machines for shared context and implement deterministic validation layers.
Because if we stay on our current path blindly, we are going to scale inefficiency and systemic failure faster than ever before.
The future of artificial intelligence cannot be human versus AI. Or even human plus AI. It must be a continuously evolving, shared cognitive ecosystem.
If we get it right, we unlock true collective intelligence.
Which brings us to a final thought for you to take away. If true collaborative intelligence requires deep shared context and continuous feedback loops, perhaps the first step to building better AI ecosystems is actually fixing how we collaborate human to human in our own workplaces.
Yeah, if your engineering team and your operations team operate in silos, you are already suffering from the exact failure modes we just described.
If we cannot build shared understanding with our own colleagues, how can we possibly expect to architect it into a machine?
Very true.
Thank you for listening to the AI for Career Success podcast from Curt Robbins, where we help you get smarter than your competition. Please buy us a coffee and remember that we're experts at coaching you and your employees about AI. We'll see you next time.